Hello, everybody, and welcome again to another OpenShift Commons briefing. We're really pleased today to have this update on Kubernetes 1.10. And we've got Cole Mickens and Stefan Schimanski, both now Red Hatters. Cole comes to us from CoreOS, and we're really pleased to have his expertise as part of this briefing as well. There's a lot in this release, so I'm going to keep this short. The format is we're going to let Cole and Stefan talk for probably about 30 minutes. You can ask questions in the chat, and then we'll open it up for Q&A at the end. So with that, Cole and Stefan, take it away.
Great. Thank you very much, Diane. All right, folks, let's take a look at what's new in 1.10. Right off the bat, we've got three key features here we want to talk about. The first is API aggregation coming to us from SIG API machinery. It has graduated to GA in this release, which is a big deal. We have the container storage interface, commonly referred to as CSI, which is graduating to beta out of SIG storage, which is providing a common interface for vendors to provide storage options for Kubernetes clusters. And finally, we have a mechanism for hardware device support graduating to beta.
Yeah, hello everybody, also for me. So we took a look at the restarts from last release 1.9 and now 1.10, and yeah, the numbers are growing extremely quickly, as you see. So we have 8,000 pull requests merged across the organization in 1.10. That's 30% more than 1.9. Of course, 1.9 was a holiday release, but still it's impressive. 90,000 comments, so very active people on GitHub commenting on issues, on PRs, and so on. I counted 1,700, or I didn't count it, but the statistics server counted it for us. Impressive number. We are still increasing the number of SIGs and working groups. So we have 29 SIGs at the moment, 8 working groups. I think we had 5 in the last release, so it's getting more. We have a list of features. 9 are alpha features, so they are really new innovation. Still going on, and 16 of them are graduations from alpha to beta or even to GA. So as you see from the numbers, stability is still a big focus. And yeah, the next slide. So I copied the next 2 slides just from 1.9. Nothing has changed. Stability is important. Production is important, so we are still very strong in fixing bugs and making sure the product is ready for production. So we refine, polish, scale, and tighten, of course, and we're trying to get all features we developed as alpha versions into beta and into GA.
This is the first release after Red Hat and CoreOS have joined forces. As Diane mentioned, CoreOS got acquired a couple months ago, and we've been integrating our teams. And I think actually on Monday, we officially became Red Hat Associates. It's very exciting times. It's great to be part of this larger OpenShift team. I'm very excited to see where this takes us.
Yeah, before we go into details, just usual words about what is alpha, what is beta, what is GA. So alpha are usually new features, or at least features which are not good enough, complete enough to graduate to beta. Those APIs can change dramatically, so don't rely on them, especially not in production. In the worst case, it can even go away. Betas are those which are on the way to stable, to GA, so those features will stay in the product. And very important for many people, those features, beta features, they are the first time enabled without feature gates. So you can really use them in nearly every cluster. Of course, in OpenShift, a lot of them are just tech previews, but still they are enabled. And very important, if you program against the APIs, beta feature APIs will stay at least 6 months, even when the GA version is out already. And finally, GA, those are the really tested, rocket-proof, stable APIs. Yeah, so we highlight a number of features sorted by special interest groups. So here's SIG auth, so authentication, authorization, or in short, everything about security. The first one, it's not that new. In fact, most of you will have seen pod security policies In short, we call them PSPs. They have started their road to GA, so they officially graduated to beta in this release. They used to be in the extensions v1, beta 1 API group, but this really didn't count much because this API group was invented before we even had alpha. So this time it's really officially in the policy v1, beta 1 API group. It's all about controlling what pods can do. So examples are you can define which volume plugins are allowed. For example, the host path volume, you can read everything from the host when it's not restricted in some way, and this can be controlled via PSPs. Namespaces, user group IDs, a lot of mechanisms from the Linux kernel. This controls, all this can be controlled, and you see it on the right, one example of such a PSP. If you want some kind of multi-tenant setup where you don't trust workloads, you need PSPs. There's no way around that. And in general, similar to the RBAC introduction in 1.6 and the following releases, expect a measured, slowly and controlled rollout of PSPs into Kubernetes by default. That's the future. They stay tech preview in OpenShift. So in 3.9, we had them already as tech preview. There are also security context constraints, which some of you might know. There is a predecessor of PSPs, and we plan to migrate them to PSPs in the next releases. It's not fixed yet when this will happen, but expect it will. So PSPs are the future. Another one about security, which is really, really exciting. If you look at the last bullet point here, what we plan to do, it's about container identity. So, service accounts allow you to do certain things in a cluster, to use certain APIs. The problem with service accounts is they are not bound to any pod. So if you steal a service account, you have the whole API, or at least those parts which are where you have permissions via RBAC, you can just use them. And this is not a good idea to have, of course, in a production cluster. So tokens are introduced now, which you can derive from service accounts. So you post to the service account resource on the API, on this token sub-resource token request. That's what you see at the top right. And you get back a JSON web token. And those web tokens, they are constrained by time, so they expire in contrast to service accounts. They can be restricted to special audiences, for example, just to the API or to parts of the API or other services in the cluster. And they are bound to pods. So if you steal such an account, such a token, you will not be able to do much in another pod. It will just not work. As JSON web tokens, they are signed by the API server, which means they are not persisted. So if you have huge clusters, and service accounts are a critical point in scaling them, those tokens are not persisted, which makes them really suited for big clusters. And there's a new endpoint on the API server to list the current signature key, so you can compare every JSON web token you get, whether it's valid or not. And some goals with them, they should be injected into the kubelet. It's not done yet, but it will be in the near future. And they should work with external services. Vault, for example, is one example. And any kind of advanced policy. So you can restrict certain tokens to just very hardened nodes, for example, to increase security even more.
Another security feature highlighted for 1.10 is support for external authentication providers for kubectl and for client Go. Again, fitting with the larger theme of out-of-tree plugins, we have a model where vendors can provide authentication plugins to kubectl without needing to modify the kubectl source code. And additionally, this functionality is available to all consumers of client Go. This functionality is going to allow vendors such as Google and Azure and other Kubernetes providers to provide plugins that allow integrations with their platforms into kubectl. Today, if you're a user of GKE, you may be familiar with gcloud and how the gcloud command sometimes wraps kubectl and injects authentication context. In the future, kubectl and kubeconfig files will be able to encapsulate that logic and call out to an external plugin. And so these providers can provide authentication options as a completely black box to kubectl. And ultimately, this provides a lot of flexibility that Kubernetes providers have been requesting.
Yeah, we have two big features from the networking special interest group. The first one is about resolv.conf, so you can finally customize the name server behavior in a container. So you can define a custom name server, and you can define search domains and even special options, and all those information. This information is written into the etcd, the etc resolv.conf of each container. And the second big feature, it's now in beta. So for quite some time, there has been work done on a replacement for kube-dns. Today, you have kube-dns, which is usually deployed, for example, with the deployment set to the cluster. But kube-dns is just a Go wrapper around DNS mask. And at the end of last year, we had another set of DNS mask vulnerabilities. And this gave another reason to continue this road. So the future will be that CoreDNS replaces kube-dns, and CoreDNS is a project under the CNCF. It's a pure Go implementation, very, very suited for Kubernetes. The basic theme, again, is fewer moving parts. Goals, simplicity, speed, of course, flexibility via plugins. So I counted today, there are 48 plugins today on the website of CoreDNS, quite impressive. And of course, ease of service discovery is a goal. I mean, with services inside the cluster, you know that already, but you can even install plugins to integrate other services from other sources. At the moment, this is beta, but we still ship kube-dns in 1.10, so it's still the default. The reason is that CoreDNS is not feature complete yet, so there are still some things missing. So when it's feature complete, we can really switch to CoreDNS. The big theme in Kubernetes, which we see here, less code in core. So we move out functionality from the core Kubernetes into sub-projects, and this is one example of that. The next special interest group is API machinery. API machinery does a lot of work about extension points, extending the API, and we have two ways to extend the API nowadays. The first one is custom resources, short CIDs, and the second one we have here, it's about aggregation. So writing your own API servers and integrating them into a cluster. And you can use those APIs, of course, as a storage counterpart for operators. So Core started last year writing operators for etcd and Prometheus. Those API servers can be used for that. Actually, so we started to use this feature for service catalog, which is for quite some time a tech preview in OpenShift. And we have started after this experience, which was really, really positive, to use this feature for the future of OpenShift. So we will move out code APIs from OpenShift into its own API server. So this is the future of the architecture of OpenShift. The basic idea is, you see it on the right picture, requests come in from kubecontrol, for example, and they reach the API server. And inside the kube API server, there is an aggregator. It's basically a proxy which either sends a request to the normal kube APIs, or it's for a CID, and it's also handled internally, or it's really proxy to the in-cluster API server. So for example, in this example here, the red arrows, it's sent to OpenShift. And you can even install your own API servers. There are more of them in the community, and you can even write your own. So the vision we have here is that you can just say Helm install and then some API server name, and it's installed plug and play. So without doing anything, certificates are done automatically, and you have new APIs to use via kubecontrol. So really a plug and play experience. That's our goal. If you want to dive deeper here in this topic, there is the library API server. It's in the Kubernetes K8s IO domain. There's an example sample API server you can look at, and we have an API server builder to help to get you started with code. As mentioned already, the second mechanism for extending APIs are the custom resources. Custom resources are limited in features, so they cannot do certain things which API servers can do. So yeah, you have to decide which way to go. Custom resources are very simple to define. That's why people you want to use them. They are without any code, just a spec which you post to the server. And we're working on making them even more native. So as a user of the cluster, you should not notice whether it's a CID or a real API server. And one feature we added now as an alpha version are subresources, which gives them features which has been known only from native resources, like the status and scale endpoint and the generation field. So everybody who writes controllers will love the meta generation field. This is now supported in alpha for CIDs. The TLDR is very simple. What you want to do is something like kube control scale. So you should be able to scale any resource. It doesn't matter whether it's a deployment set or something which is native, or it's a CID, for example, a cluster size of the cluster API project.
We've got some updates from SIG storage. To start off with, we're going to talk about container storage interface. Particularly Kubernetes support for the container storage interface is now in beta in this release after being introduced in 1.9 as alpha. Fitting in with the larger overarching theme, this is again supporting an out-of-tree plugin model versus previous plugins that have been built into Kubernetes core. And ultimately, this is going to allow for installing volume plugins via daemon sets. And what you should be thinking about here is CNI plugins. When CNI plugins first came on the scene, they were being deployed manually as part of the installation process for Kubernetes, and quickly graduated to the point where, for example, when you do a kube-dns install, you can actually just kubectl apply and install your CNI plugins after kind of bootstrapping your cluster. And we're seeing the same thing start to develop for storage interfaces as well. And we're going to see a number of vendors stepping up and building in plugins for their various storage products. And there you can actually see a list of available drivers already. NFS is a sample, Portworx in alpha, OpenSDS in beta, and then various sort of pre-production releases for Scale.io, vSphere, RBD, and Cinder. This slide touches on a number of enhancements that are going on in regards to local persistent storage. First off being local persistent storage itself graduating to beta in this release. This is a functionality that allows for pods to request persistent storage on local node disks. As a result of this, the pod needs to be able to specify which node it gets scheduled on so that it is always scheduled to that node so that it can access its node storage. That's a typo, that should say 1.9. This was done via an annotation, particularly specifying the Kubernetes volume node affinity annotation. And this is graduated as part of the release to beta to being a node affinity field in the persistent volume specification. Local ephemeral storage now has the ability to specify quota constraints. This functionality is in beta. Prior to this functionality, pods had no ability to make guarantees about the amount of ephemeral temporary scratch storage that they would have. And so it's possible if they were processing some sort of job and were co-located with another pod processing a large job, that they could be fighting with each other for disk space, and ultimately you could have sporadic failures. With this functionality, pods can now directly make requests for ephemeral storage and make assumptions that they will be getting that full amount of storage. And then finally, we have a beta feature, topology-aware volume scheduling, that allows to specify scheduling constraints for persistent volumes that will actually happen after the pod is already scheduled. This is useful, again, for local volumes that need to specify affinities to specific nodes. And in the future, this is going to be expanded and be much more useful by allowing specification of region constraints around persistent volumes, such that you can make guarantees that your PVCs will have persistent volumes created in certain regions matching where your pod started running. Today, this requires an amount of coordination on the deployer to ensure that these things are done correctly and that you don't have a pod talking across regions to storage. There's a large number of other smaller storage features that have landed for 1.10. particularly deleting the persistent volumes when they're in use. As it happens today in 1.9, you can accidentally walk up to your cluster and delete PVs and PVCs that are currently in use. And there's 2 new features to prevent this. There is online support for resizing persistent volumes that is in alpha that allows you to enlarge the underlying volume without taking it offline or without stopping your pod. There is support for resizing flex volumes as alpha. If you're not familiar with them, flex volumes were the first attempt at providing a way of installing external storage mechanisms into a Kubernetes cluster. It has been largely replaced by the container storage interface, but it's nice to see that for the existing flex volume plugins, there is now resize support. And then we have detailed storage metrics of internal state that are being published to the metrics server. These metrics are now being considered stable, and there's a link to a full list of metrics there, but they include things like the number of bound PVCs, the number of PVCs that failed to provision dynamically, the number of PVCs that succeeded to provision, etc. And then finally, we have a number of advanced options that are new in beta around mount propagation. And this allows things like container workloads to mount mount volumes, and they may make them available to the host, as well as the host to mount volumes and make them available inside of the container mount namespace as well. Next up is SIG-node. The first feature we're going to talk about for SIG-node is dynamic kubelet configuration. This is still alpha in 1.10. It was introduced as alpha in 1.8 as well, but it has experienced yet more stabilization. And again, there is a call for users to give this a shot. One thing I will say about dynamic kubelet configuration is that the docs are pretty advanced and pretty sophisticated for it. And so if this is a scenario that interests you, please check out the docs, walk through the scenario and see what works for you and what doesn't. Ultimately, this feature is built to allow cluster operators to be able to change options in the kubelet without having any downtime. And you can see an example there on the right. We've taken the kubelet configuration, an example of it at least, in its configuration file format, and it is actually being installed into the cluster as a config map. And then as a subsequent step here, you would be updating the node objects in Kubernetes to point at this config map and tell it to source this config map as the source of configuration for the kubelet. And if the administrator needs to come along later, they can actually update this config map and then update the node configuration to point at the updated config map to realize these changes without needing to SSH into their nodes. There are a number of enhancements that have been created by SIG-node for performance critical workloads. The first of which is moving the device plugins API to beta. Device plugins API is again an out-of-tree plugin model that allows vendors to advertise advanced features to, in this case, the kubelet. These are things such as GPUs, FPGAs, high-performance networking interfaces, InfiniBand, and much more. Really, anything you can think of that falls under the category of hardware features can be advertised to the kubelet. Historically, again, this is something that had to be built into core and was limited by Kubernetes velocity, and now can happen at the pace that the vendor would like it to happen at. And currently available, there are 2 different GPU plugins for NVIDIA. There's an RDMA plugin, and there's a SolarFlare plugin. And then there you see the little code snippet. These are consumed much like any other cluster resources. 2 additional features here. One is application CPU pinning. This is a beta feature and is a change in behavior to the pod spec that is activated when the kubelet is configured to use a static policy for the CPU manager policy. The TLDR here is, we're just going to look at the example. In the example, the container does not make a request for resources. It only specifies limits. And the Kubernetes behavior here is that the requests automatically are set to the same values as the limits. And in this case, because the request is for 2 CPUs, 2 is a whole integer value and is greater than 1, this actually activates guaranteed mode and activates this application CPU pinning feature. And in this example, the Nginx container And note, it's the container, not the pod. The Nginx container actually gets 2 full exclusive CPUs guaranteed to it. And those are removed from the CPU pool that the kubelet is then using for any other pod. And then the other big feature here is huge pages in containers. So nodes can now allocate and advertise huge pages, and the kubelet will expose them as a scheduler resource. And much like the device plugins API on the previous slide, you'll see that these are consumed via resource limits for the containers, similar to other cluster resources, and they are surfaced to the container via a huge pages volume type. And we want to make a note here, if these sorts of performance critical workloads are important to you, we encourage you to join the resource management working group to help the community deliver even more improvements. And then finally, we have some updates to the container runtime interface. It is still, or the first feature is in alpha, and it adds support for Windows container configuration. You may be confused since Kubernetes has supported Windows containers for a while. It just turns out that it has not supported resource constraints for these containers previously. In fact, if you've specified them in the past, they were being ignored, and they were instead being set to the host's Docker's default configuration. With 1.10, the interface has actually been revved. It's now v1 alpha 2, and it now includes a Windows container config struct, enabling the pass-through of these constraints from the Kubernetes manifests all the way down to the runtime. And we also see the CRI validation test suite graduating to beta with this release. As I mentioned, there's a new CRI protocol version. It did have breaking changes. So for Kubernetes 1.10, you'll need to make sure that your CRI tooling is using v1 alpha 2. And as such, there's a new v1 beta release of the CRI validation test suite. And then finally, STIG Azure has some features in this release and the feature tracking spreadsheet, and we're going to talk about them. There is an initial implementation for Azure KMS, which is an implementation of Kubernetes KMS, which, if you're not familiar with it, is a mechanism by which providers can plug into Kubernetes and provide sort of a translation layer between etcd and its final storage, allowing for encryption of etcd and the secrets stored in etcd at rest. So for Azure, this is done via Azure Key Vault. This is again, an out-of-tree repository. You'll see this actually lives in the Azure organization, but it includes instructions for how you would deploy this in a Kubernetes cluster and configure Kubernetes to take advantage of it. Also in alpha, Azure now has support for virtual machine scale set, which is their higher level concept for multiple identical virtual machines. Previously, the Kubernetes cloud provider support only supported loose individual VMs that customers had to manually orchestrate. But now there is full support, including attachment and detachment of persistent volumes to individual machines in one of those groups. And then finally, we have autoscaler enhancements. There was previously support for scale set VMs in the cluster autoscaler project, but the majority of Azure deployments were using loose VMs. The Azure team has done work in the autoscaler to support both of these types. So hopefully all Azure customers can be covered by the cluster autoscaler in some capacity now.
Yeah, this was an overview of features, a selection of features. I think there are many, many more, which we haven't mentioned here. If you go to the next slide, we have listed the special interest groups. I mentioned 29. Yeah, you see the list. So if you're interested in some topics, go to those meetings. So in the community repo, there is a page for each of them with the meeting times, usually every 2 weeks or something like that. Join them, participate, drive the project, create the future. Yeah, that's basically what you want to say.
No, awesome job, guys. There was quite a bit in there, and it may be a little overwhelming for some folks who, if you're just coming to this now, and we'll see if we have any questions here. So far, there haven't been any questions in the chat. So if someone has a question, type it in the chat or raise your hand, and we'll unmute you. But I think, as you can see, there are lots of aspects to this release, some of which are getting incorporated into OpenShift 3.9, and some of which we'll be testing out and integrating over the coming months. But if you've got a question, please feel free to reach out to either Paul Mickens, myself, or Stefan, and let us know. And we will be posting this video and the slides as well. And most of the slides have links embedded into them and point you to the resources you need. We also have another briefing coming up tomorrow with Tigera. A couple of their technical folks are going to come in and talk about Contrail and using it with OpenShift. So if you got any questions, this is your opportunity. If not, we will give you all back a half an hour. Anything else you want to add, Cole or Stefan?
I think I just echo your comment, Diane. Stefan and I have made efforts to make sure that the slides have links both to documentation as well as feature proposals and in some cases pull requests. So if you want to know more, definitely check out the links in the slides. And then again, as Diane said, please reach out. I'm happy to chat about these things. So.
And of course, there are very long release notes, complete release notes, 40 pages or something like that. So it's also a big source for more information.
Yeah, and there's also a couple of write-up blogs. I'll add them in when I post this video on blog.openshift.com. Links back to some of there's a very nice blog that Eric Chang wrote on the CoreOS site, and there's a couple other ones that are out there too. So hopefully we can get you everything you need to get up and running, and we're looking forward to 1.11 because every 3 months we like to bring out new things. So thanks again, guys, and we'll talk to you all again tomorrow morning.